Hello, I am Esteban Carissimo, and my presentation will show the deterioration of Venezuela's internet infrastructure, and we hope our results can help future reconstruction plans in the country. To get an idea of our paper focus, we'll discuss Venezuela, a country in North and South America, and we contextualize our results with country in the region administered by the Regional Internet Registry, LACNIC. Our comparison will also focus in other countries of the regions that have been historically the largest economies along with Venezuela. Our work is motivated by the crisis in Venezuela, which has far-reaching implications across all areas. This crisis has led to research in fields such as public health, energy, and water management. These studies investigate the severe consequences of the crisis on the quality of life. Our paper is the first of its kind to examine the profound impact of Venezuela's crisis on internet services over the past decade. And looking ahead, the normalization of the country will eventually happen. The country is devastated by a prolonged crisis and needs reconstruction plan for all sectors, and the internet is no exception, as it's a critical component of modern society. However, no recovery plan can be done without understanding the current state of the internet. So before going into the deterioration of the internet, we need to give some context. Venezuela is a petrostate. The country sits on top of the largest proven conventional oil reserves. And the government budget heavily depends on these reserves, as 2/3 of its income comes from oil exports. However, the economy is tied to oil prices, as this figure displays. The 1980s drop led to Chavez's rise to power, and the 2014 drop had a devastating effect on Venezuela's economy. But all this economic collapse occurred in a country already facing institutional challenges. After winning the 1998 election, the government embraced economic populism, pushed constitutional reforms that annul virtual lifelong presidencies, and all these policies led to a severe deterioration of civil rights. To get more context of the country, I highly recommend this book by Ricardo Hausman from Harvard. And now, to obtain an internet perspective of the country's deterioration, we'll use the multiple data sets. To get a perspective from the internet infrastructure, we use telegeographies and CADA's datasets to see the submarine cable deployments and the growth of peering facilities. We use other datasets from CADA to see the role of the state-owned CanTV. We use data from RIPE to see local root DNS server deployments, and other data from RIPE and MLab to see user experience, such as the proximity to public servers and user bandwidth. All these datasets can give us a longitudinal view of the crisis of at least 10 years. Now, let's examine the impact of Venezuela's crisis on its internet infrastructure. And we're going to start by looking at the submarine cable growth in Venezuela. As this map shows, only one cable was planned and deployed during this administration, and it only connects to Cuba. And I would say that Cuba benefits more from it than Venezuela. But Venezuela contrasts with the rest of the region. The region experienced a bonanza driven by the rise of commodity prices, which is also reflected in its submarine cable deployments. While Venezuela did benefit from this bonanza, it did not impact its submarine infrastructure. Peering facilities are another critical component of the physical infrastructure. Venezuela evolved from reporting 0 peering facilities to 4 between 2018 and 2024. But in contrast, the LACNIC region as a whole reports 600 facilities, with Brazil reporting approximately 300, and other countries such as Mexico and Argentina reporting 50 each. We'll also examine the consequences of the crisis on network connectivity of CanTV, the country's most relevant provider. To provide some context, CanTV was renationalized in 2007. It serves the largest user population in the country with approximately 25% of the eyeballs, and theoretically offers affordable subscriptions. Now let's look at this heat map of CanTV upstream connectivity. The x-axis displays time here, and the y-axis displays all the list of all providers serving CANTV at some point in the past 25 years. In this map, a colored cell indicates that the upstream provider was connected to CANTV at that time. We use two different color tones, brown for international providers and blue for US-based providers, and also the US-based providers have bold fonts on the y-axis. So CANTV was losing upstream connectivity in the past years, in particularly US-based providers. Why? This is partially the result of CANTV insolvency and also from economic sanctions imposed to the country. IXPs are another critical infrastructures to enable local connectivity as they enable local settlement-free peering. So we examine the IVOS population of each Latin American country connected to the largest IXPs in Latin America. So let me explain this heat map here. So we have in the x-axis the largest IXP in each Latin American country. In the y-axis, we have the IVOL the location of the IVOLs, and each cell displays the fraction or the percentage actually of the country's IVOLs population connected to the IXP. For example, the example shows that 62.4% of Argentina's IVOLs are connected to RIX. So what happens with Venezuela here? So Venezuela has no IXP yet. While most of the Latin American countries encourage and deploy their own local IXP, Venezuela is an exception, with other countries such as Uruguay. But the main difference with Uruguay is no Venezuelan network is connected at any Latin American IXP. This contrasts with Uruguay that is present in Argentina, Brazil, or Chile, but Venezuelan's networks are not benefiting from these peering fabrics. We now focus on internet services using DNS as an example, and we're going to see deployments of local root DNS servers. Two root DNS servers were installed in Venezuela, and they are present in the country's two largest cities, Maracaibo and Caracas. The L root is both in Maracaibo and Caracas, and the F root is in Caracas. However, when we look at the measurements, we see that these servers in Venezuela are unreachable. And in contrast, the region has expanded the presence of local root DNS servers deployments, doubling the number in the region regionally and in countries such as Brazil and Chile. And our next analysis focuses on latency to public DNS resolvers as a proxy of user experience. When we looked at the trends of the latency from props in Venezuela to Google's public DNS resolver, we see that it's very constant at approximately 40 milliseconds. When we look at the geographic distribution of this, we see that props in the Colombia's border, not connected by CANTV, show a better latency. But this contrasts the overall picture of Venezuela's contrast with LACNIC, as the latency to Google public DNS doubles LACNIC and doubles most of the country in the region. Alternate deployments is another critical thing to improve user experience. And the alternate deployments in Venezuela is a two-tiered story. When we look at two CDNs like Google and Akamai display here, with alternate deployments before the crisis unfolded, the fractions of ILO served by alternets was similar in Venezuela and the rest of the region. But when we look at CDNs such as Facebook and Netflix that deploy these alternets after the crisis started, we observe that these deployments were first delayed and the population covered is smaller than in peering countries. And our last analysis in this presentation examines the bandwidth evolution in Venezuela as another metric of user experience. Venezuela's bandwidth stagnated at 1 Mbps for a decade, while bandwidth consistently improved across the LACNIC region during the same period. However, we can see here that this is a huge contrast because Venezuela is at 3 Mbps and the rest of the region is at 20. But however, the speeds in Venezuela have recently recovered, driven by the introduction of new high-speed services. However, these services remain quite exclusive as they cost 10 times a minimum wage. And despite this recent growth, Venezuela still lags behind the rest of the region. So to conclude this presentation, let me talk about the past, the present, and the future of Venezuela's internet infrastructure. So in summary, Venezuela's crisis has severely impacted its internet infrastructure, which has seen no investment over the past decade. This led a deterioration on the network connectivity, resulting in a degradation of the user experience. But what now? The country will eventually normalize, and we explore how different sectors could contribute to this effort. First, improvements in connectivity. Venezuela can benefit from reestablishing past relationships. We see that some providers stop serving CanTV, they can be reestablished. We also think that restarting pre-existing infrastructure, we didn't see any path going to local root DNS servers. So we think that optimizing routing to in a use path could benefit Venezuela quite quickly. And the third part is the most difficult one, which is new infrastructure deployments, which means investments in public resolvers, submarine cables, PM facilities, and other key infrastructures. Thank you for watching this presentation, and I'm happy to take any questions when we meet at SIGCOMM or by any other means.